Now, one very common doubt that I come across whenever I teach combinations is when we have these kind of problems, say for example, suppose we have 5 men and 3 women and we have to select a committee of 5 people so that it should have at least 3 men. Now we know how to solve these problems, so we'll consider 3 separate cases. Case 1, when the committee has 3 men, 2 women. Case 2, when it has 4 men, 1 woman. And case 3, when it has 5 men and 0 women. Now, how do we select 3 men out of 5? So which is simply 5C3 and then 2 women. So that is 3C2. So it is 10 into 3. So it is 30. Now 4 men. So that's 5C4. 1 woman, 3C1. So which is 5 into 3. It is 15. And then 5 men. So 5C5. 3C0. And it is 1. So if I'll add them all, then I'll get 30 plus 15 plus 1, which is 46. So there are total 46 ways in which I can select 5 people so that it has at least 3 men. Now the doubt that I generally have is, why can't we do it in this way? Say for example, what we'll do is, out of these 8 people, we need at least 3 men. So what we'll do is, we'll first select 3 men. So we'll select 3 men, and then from the remaining, how many people? From the remaining 5 people, we'll select any 2. So select 3 men. So from 5 men, we need to select 3. So that is 5C3 into, now remaining 5, I need to select any 2. So that is 5C2. Now 5C3 is 10. 5C2 is also 10. So it is 100, which is much greater than this value 46. So if we are going to go this way, then obviously there are some cases which are counted twice. Now, why does that happen? Now what I'll do is, I'll take the simple case when I'm selecting 5 men and 0 women, and it shows there is only one case, right? So if there are 5 people, A, B, C, D and E, all of them they are men, and if I have to select 5 men and 0 women, then it is 5C5 into 3C0, which is only one case. Now, if I'm going to go in this way, then what I'll do is, I'll first select 3 men. So in how many ways can it be done? So from 5, we need to select 3. So that is 5C3, and then from the remaining 2, I'll need to select 2. So that is 2C2. So now it becomes 10 into 1. So which is 10. So this case, which actually is only one case, is counted 10 times and I'm getting 10 results. So all these 10 results, so what it is nothing but distribution of A, B, C, D, E. So either we can select them as A, B, C and D, E, or A, B, E and C, D, or A, B, D, C. So all these 10 cases, they are equivalent to only one case where I've selected only these 5 men, which is A, B, C, D and E. So that is the reason we cannot solve this question in this way. So when I'm solving this question this way, when I have 3 men, 2 women, 4 men, 1 woman, 5 men and 0 women, I can do that because the set of men and set of women, they are disjoint sets. So there is no element which is common to both the sets. But if I'm doing it in this way, that I select 3 men first and then 2 from the remaining 5, in this case, these 2 sets, they are not disjoint sets, and that is the reason I always get a wrong answer in this case. So whenever we have such situation, always make sure you are doing it in this way.